The current focus of the industry and of the regulatory community is on monitoring and reporting current emissions levels. We know this data is becoming more important. So a lot more scrutiny on the data that operators report through their permits. Many eyes looking at it, not just the regulators with new requirements, but a third-party community of NGOs and community activists that are paying a lot more attention to the data than we have before. So there's a critical need to measure what matters and to get that right. And then we've been talking through this lesson on environmental stewardship about just how we're trying to do that. And there's a lot of effort that's going on in this space. My name is Jim Crompton. I'm a professor of practice in the Petroleum Engineering Department at Colorado School of Mines. And I've in working with the Payne Institute of Public Policy at the school in order to try to figure out how to do a better job of understanding the data that we collect. Well, we've been talking through most of this lesson about current activities, and I wanted to end our session here with just a few thoughts about what's next. And, once we get to a very good understanding of what is going on, maybe might be able to actually build simulation models to predict in the future what might happen. Now, this prediction has to come through another sort of simulation routine. That's how we can play it forward into the future. It's going to have to challenge a couple of different opportunities to work on it, because essentially what we are monitoring is not a static, automated, continuous process. There's a lot of change in the oil field. As the reservoir gets older, its gas-oil ratio might change. All of a sudden, we're producing more methane and less crude oil, so we have to deal with that. Facilities change. We may have flowing well heads at the beginning, but then quickly move to artificial lift as the reservoir pressure declines. We may be able to make changes in our facility and replace diesel power with electric power. And that, again, changes the emission footprints as we're going on. We might even be able to connect the facility with pipelines rather than tank farms. And again, changing the emissions profile of those kind of efforts. So there's a number of things we can do that modeling would help. And our simulation model is often called in the industry a digital twin, a mathematical model of the physical process that has been trained by real data, operational data. And now it allows us the ability to play what-if games, whether it's drilling more wells, changing some of the facility itself in order to minimize or maybe even eliminate, the methane, kind of emissions. So this concept of the digital twin for all of this is going to be an interesting kind of trend going forward. Today, we already know, essentially, to a pretty good degree, pretty sophisticated degree, how to simulate the reservoir, which is obviously one of our major components of this system. Even though, it's mostly built on indirect measurements, we understand the physics of that process well enough to create reservoir simulators. Now, on the top side, we can do similar things through process simulators, and we can model what I might call the sales stream, the amount of crude oil and natural gas going through the pipelines, going to a sales meter, having a trusted, kind of measurement where both the buyer and the seller kind of agree on volumes. And we can get this whole idea of everything we need of good measurements, good prediction models, verified, sales measurements, etc. And all of that is pretty much, kind of what we can do today, conventional knowledge. But I think with its emissions challenge, we need to add on to that model a simulation of what I might call the waste stream, the flaring, the venting, the fugitive emissions from, critical equipment or tank farms or whatever, or even just the process of the trucks unloading volumes from the tanks. all of that is a problem that we have some of the tools, we have some of the knowledge, but it's still kind of a problem to be solved yet. And while we're working on elements of that, it's a adding to our traditional knowledge of the oil and gas system with this idea of what changes and what escapes essentially from our systems. That waste stream modeling is what I think might be the future of the digital twin in this kind of space. Well, it's going to have to involve some of the current simulators, our computational fluid dynamics, physics-based driven model of the reservoir, computational fluid dynamics of the process model, where it goes from wellhead to separator to vapor recovery unit to the tank farm, et cetera. So, we have some of these different tools, and we often have to start with an idea of a finite element analysis of the critical pieces of equipment. But the remaining piece of it is kind of something new, and it's something we have to borrow from the environmental air quality kind of community of that of the dispersion model. Well, today what we're really measuring essentially is the increase in methane molecules in the air volume, or that is the wind is blowing, essentially past our sensors, or maybe even more remote sensing platforms like drones or aircraft or even satellites. So as we begin to try to match this, we have a different integration sort of problem. We have a digital twin too, if you will, that's going to measure the total system from the sales stream plus the waste stream. This is going to be an interesting challenge to build these models and build them to the degree of accuracy that people will trust. That essentially, while no model is perfect, but we can get models that are accurate enough to be useful, and that the use has a value proposition for the operator, as a value proposition for the regulator, as a value proposition for interested third parties. So I hope you enjoyed the lessons in our environmental stewardship session, and continue to be involved in this ongoing challenge of reducing the methane emissions and the carbon dioxide, the greenhouse gas emissions from oil and gas operations. Thank you.